Naming alkenes is actually relatively simple, and if you know how to name alkanes, then you're like 90% of the way there. So what is an alkane or alkene? It looks pretty much just like an alkane. However, now we have a double bond introduced here. So we need to name it as such. They're named in similar fashion where we have a prefix, which is the number of carbons, plus a suffix denoting what type of molecule it is. The suffix for alkenes is just -ene. And the prefix, like I said, is based on the number of carbons. So what we do here is we just count how many carbons in this chain. We have 1, 2, 3, 4, 5, and 6. So hex would be our prefix, and our suffix is -ene. So hexene is the name. But we have to go one step further because hexene actually describes multiple molecules. We have to say where this double bond is. And similarly to substituents, we always count in the direction that gives the double bond the lowest number. So we wouldn't count this way, we would count this way. So 1, 2, 3, 4, 5, and 6. We would say that the double bond is at the 2 position. That's where it starts. So a double bond that goes from 2 to 3 would be at the 3 position. The double bond that goes from 2 to 3 would be said to be at the 2 position. If it was going from 3 to 4, it would be said to be at the 3 position. And if it was going from 1 to 2, it would be said to be at the 1 position, and so on. You would not say at the 5 position, 5 to 6, because then we'd count back the other way. So, and there's 2 ways to do this, because one is an updated nomenclature for IUPAC, one is the older one, but it's still so commonly used. So right here, this is the common one, it's 2-hexene, and this is what I was taught. Now, you might see newer textbooks or just newer professors, whoever, say this is hex-2-ene. Now, technically, this is the most updated, but both are very commonly accepted within chemistry and considered both valid ways to name this. So now, what do we do if there's a substituent on here? Well, we name it the same as just if it was an alkane. And so say there was a methyl group here at the 5 position, that would be 5-methyl hex-2-ene or 5-methyl-2-hexene. And there's actually one more thing I forgot. So if you notice here, or hopefully you've learned this, when you have a double bond, we do not have free rotation. We are locked here. So these are both locked facing away from each other. This is what's known as a trans double bond because they are facing away from each other. There's similarly a cis double bond. So not only when we say 1-hexene, or 2-hexene, I'm sorry, so 2-hexene, we'd have to say, is it cis or trans? This one would be trans. Or maybe more accurately, we would call this E2-hexene, because that is E is when we have things that are not the same and they're facing away, and Z is when they're facing the same side. Because now we can draw the cis one real quick. What would the cis one look like? So we draw this the same way, where we have a double bond here, except now they have to face the same way, like this. So we 1, 2, 3, 4, 5, 6. This would be cis-2-hexene, or if you're using Z nomenclature, you'd call this Z2-hexene. And it's important to note that this is for just when you have, I guess, only one substitution on either side. It's pretty easy to call that. Now, what do we do when we have multiple things on that alkene? So we have something like this. So let's just keep rolling with our hexene example. 1, 2, 3, 4, 5, 6. So say it's right here at the 2 position, just 2 position on the other side. And now we have a methyl group right here. Okay? So like I said, we name this as a substituent. And this would just be what? This would be 3-methyl-2-hexene. Or you could say hex-2-ene. Wow, my handwriting's terrible. Hex2ene. I'll fix this as well. Now remember, I said we have to say if this is cis or trans, but trans just means this, where there's only one thing on either side, and cis means there's one thing on either side, but now they face the same way. This is two things on one side. Well, what do? We have to name them with the E and Z nomenclature that I mentioned previously. And we do that with what's known as the Kahn-Ingold Prelog method of naming convention, and that's the same priority convention we use when we're determining chirality. You're going to learn about that later on. So what we do is we split the alkene like this, and we're going to draw in that implicit hydrogen. And what we do is we determine a priority group for either things on these sides, and we go by atomic number. So whatever has the highest atomic number wins. So carbon beats hydrogen. So this is 1 and 2. So this is a carbon and this is a carbon. So what do? We go by what they're then bonded to. This is a carbon bonded to 3 hydrogens. This is a carbon that's bonded to 2 hydrogens and then another carbon. So this side wins. So we're going to say 1 and 2. And then what you do is you see where the most important priorities are relative to each other. In this case, the most important priorities are facing away. So this specifically would be E. For, I believe it's entgegen. It's from the German, and I'm probably mispronouncing that. But this is what we would call it because they're facing away. Now, if it was the other way, here, I'll redraw this. We're going to name it the exact same, except we're going to change that E to a Z. So what would that be? We have, 2-hexene, and we have 1, 2, 3, 4, 5, 6, and we have the 3 on our methyl here. So now we have the implicit hydrogen here, and we'd rate this as 1, 2. I think my pen's dying, guys. 1 and 2. So now the most important priority groups are on the same side. So that's going to change this to a Z for Zusammen, I believe. Again, I'm probably mispronouncing it. It's from the German. But a way people remember this with the Z is Z is same side. It's like saying Z is the same side. Z is the same side. That's how people remember that. So remember, cis and trans only refers to when you have, here I'm going to change that, a double bond that only has one thing on either end. So this would be your trans, this would be your cis. When we have anything more on here, now we have to start using E and Z nomenclature. And technically, cis and trans would fall under E and Z nomenclature. It's just, we can just easily say cis and trans, so you don't have to think about it. So basically, all cis and trans are E and Z, but not all E and Z are cis and trans. And that's why we have to use this E and Z system for more complex alkenes like this. Now we're going to get into something else. And I want to say that generally, with your alkenes, if it can be cis or trans, it's generally assumed to be trans because that's the more stable conformation. What do we do if we have multiple double bonds? So 1, 2, 3, 4, 5, and 6. So what do we do when we have this? Well, that's too easy. This is our hexene again. That's hexadiene then. Diene? These are what's known as dienes. So you use the prefix for the carbons. We had an A on there now, so hexa, and suffix diene, indicating that there are 2. Similarly, we can put a third one there and call that a triene. Now, for something like hexatriene, by definition, you can kind of, I shouldn't say by definition, we have to then say where these are, because technically you could have the allenes, the whole other thing. We have to say again where these are. So it'd be 1, 2, 3, 4, 5, and 6. Now this is a symmetric molecule. It doesn't matter which way we name it. So we'd call this 1. There's 1 there at the 3, at the 5. So we just call this 1, 3, 5 hexatriene. And say we again just keep using our hexene example. 1, 2, 3, 4, 5, 6. Say we have this. Goes one. This one's a little tougher. So hexadiene 1, 2, 3, 4, 5, and 6. This would be 1, 4 hexadiene. Now again, you should be I can't think of the word right now. Oh my God, clarifying whether if these are cis and trans double bonds. Or again, if now we put substituents on here, we have to say if these are E and Z. So always remember to be doing that. Generally though, if someone just says 1,4-hexatriene, they're referring to where both double bonds are trans. But always make sure you clarify that with them, or you clarify that to them if you're the one talking about it. Generally, when we talk about our dienes, or just alkenes in general, usually you are referring to the trans alkene because that is the more stable conformation. And I hope this helps you. Check out the other video on naming alkanes if you haven't gotten there yet, and I'll put out some more on other naming groups. Be sure to hit that follow button.